So hi guys, welcome back. So for this video we're going to discuss about friction and wedge. Okay, so we have here the block A supports a load of 100 kilonewton. So we have here a load of 100 kilonewton and it is being raised by forcing the wedge B under it. The angle of friction for all surfaces in contact is 15 degrees. If the wedge had a weight of 40 kilonewton, what value of P would be required? A to start the wedge under the block, okay, and B to pull the wedge out from under the block. Okay, so for this video we're going to solve letter A, and for your activity, for your exercise or sample computation, you do letter B. Okay, so the first thing that we need to do is to draw our free body diagram. So we have here block A and we have here block B. Okay, so what are the forces present? Okay, so for block A, let's start here. We have a contact surface here, therefore we're going to have a normal force. Okay, so we're going to have here a normal force. And if the motion of our P is towards right, therefore this block is going upwards. Since the direction is going up, the friction force is going down. So this is N1, this is F1. Okay, next would be R2 here, but I am not going to base my R2 here. I'm going to base it here. Okay, so take note, I am pushing this wedge here towards right, therefore the friction force is towards inclined left. Okay, so this is F2, and you have here a normal force because you have a contact surface between A and B, so this is my N2. Okay, so next would be, I will translate this to block A. So since F2 here is upward inclined left, this time it would be towards right. Okay, decline, directed towards right, and it is on a declined manner. So this is F2, this is also F2. N2 here is downward, so N2 here would be upwards. Okay, so here what we're going to use would be the resultant. So it would be a lot easier because if we're going to use F1 F1 F2 N2, F1 N1, or F3 N3. We forgot this. Let's finish this first. The motion of P is to the right, so the friction force with respect to the contact surface here is towards the left. Then you have a normal force here. So like what I've said, what we're going to use are the resultants so that we can minimize our solution. So we can do away with so many summation of forces, horizontal and vertical. Okay. So to get the resultant of R1, it would be 15 degrees. Take note that the angle of friction on all surfaces in contact is 15 degrees. So from the normal force, we have 15 degrees going to F1. Okay, so this would be our resultant. Then for R2, it is 15 degrees from N2. So this would be our resultant. And for F3, it is 15 degrees from N3. So this would be our resultant 3. Okay, so we are now ready to use our resultant. So we can now solve. So let's start with block A. Or from block A to wedge, and from the wedge to P. Okay, so summation of forces along x-axis is equivalent to 0. All forces that are pointing towards right should be positive. So what are those forces? We have R1. The horizontal component of R1 is a cosine function. Okay, so adjacent over hypotenuse. So that would be R1 cosine 15. Okay. Next, we have R2. R2 is a function of sine. take note that R2 here is with respect to the horizontal axis. So therefore, the angle involved, it is 20 plus 15, that is 35, and it is towards right, therefore it is positive. R1 by the way is negative, so plus sine. So we have here R2 sine 35 degrees is equivalent to 0. Now take note, I am interested in solving for R2 because if I can solve R2 here, I can translate it here. If I can solve R2, then I can solve for the value of P. Okay, so R1 in terms of R2. Okay, so transpose this to the other side of the equation to make it positive. We have R1 cosine 15 is equivalent to R2 sine 35 degrees. So R1 is equivalent to R2 sine 35 divided degrees over cosine 15. Okay. Next, summation of forces vertical or y. Okay. Summation of forces y is equivalent to 0, or vertical, all forces that are pointing towards up or upwards should be positive. Okay, so let's define our x and y axis here, since what I used is x and y. So this is my x-axis, this is my y-axis. Because of course we can tilt this, no? But if we say vertical, of course that's vertical and this is horizontal. So summation of forces along y-axis, what are those forces? We have negative 1,000. What else? We have the vertical component of R1 is a function of sine and it is negative. Negative R1 sine 15, but for R2 it is a function of cosine and it is pointing upward. So plus R2 cosine 35 degrees is equivalent to 0. So substitute the value of R1 here. So we have here negative 100 minus, what is the value of R1? R1 is R2 sine 35 degrees divided by cosine 15 times sine 15 plus R2 cosine 35 degrees is equivalent to 0. Then input that in your calculator, negative 100 minus alpha x sine 35 divided by cosine 15 times sine 15 plus alpha x cosine 35 is equivalent to 0. So R2 therefore is equivalent to 150.27 kilo Newton. So I can now translate R2 to this value here. So this is R2. So from here, I'll be using summation of forces vertical, summation of forces horizontal again. Then we can now solve for the value of P. So take note, though, for the free body diagram of the wedge, we have here the weight of the wedge, which is also 50 kilonewton. So we're going to add that. Okay, so we're going to use summation of forces along the x-axis is equivalent to 0. All forces that are pointing upward should be positive. Okay, so what are the forces along x-axis? We have P. Then we have R3, which is towards left. So minus R3, and it is a function of sine. So sine 15. Then we have here R2, and it is a function of sine. So plus, or yeah, minus, because it is pointing to the left. Minus R2 sine to 35 degrees. 15 plus 20, that is 35 degrees. And that's it. Equate it to 0. Okay. Next would be summation of forces along the y-axis is equivalent to 0. All forces that are pointing towards right should be positive. So what are those forces? So we have here negative 40. Negative 40 Then the vertical component of R3 is a cosine function. So, and it is pointing upward. So plus R3 cosine 15. R2 is the vertical component of R2 is a function of cosine, and it is negative because it is pointing downwards. So R2 cosine 35 is equivalent to 0. So 1, 2, 3. So that's it. And we are interested in solving for the value of P. We should have substituted the value of R2 first. Okay. So from, let's say this is my equation 1. So from 1 we have P. No, transpose this to the other side of the equation. We have R3 sine 15 is equivalent to P minus R2 150.27 sine 35. Then R3 is equivalent to P minus 150.27 sine 35 divided by sine 15. And this is my equation number 2. So substitute this in 2. So we have sub 1 in, let's say this is equation number, actually this should be the same. Sub, let's say this is 3. Sub 3 in 2. So we have here negative 40 plus, what is R3? We have P minus 150.27 sine 35 divided by sine 15 then equation number 3 or number 2, cosine 15 minus 150.27 cosine 35, equate that to 0. So we can get the value of P. So negative 40 plus alpha x minus 150.27 sine 35 sine 15 cosine 15 minus 150.27 cosine 35 is equivalent to 0. So that is 129. The value of P is 129.89 kilo Newton. So this is the value that we need in order to start block P. Okay. So to pull the wedge out from under the block. So this time the direction is towards left. Okay, so that would be your practice problem.